Perspective Class 3 Video 2. In this video we're going to talk about the line and the ray generated by a vector. So let's go straight to a definition. This definition says that the line generated by a vector v equals ab is simply the line obtained by taking all the scalar multiples of the vector v. So in the previous video we spoke about scalar multiples and how when you scalar multiply a vector, what happens is you stretch or shrink it or you reverse its direction. But it's important to note that all scalar multiples of a vector, they all lie on the same line. So if I consider taking all the possible scalar multiples of a vector, that sort of traces out a line. So let's just look at an example to see what's going on. Calculate the line generated by the vector v equals 1, 2. So I've already drew the vector v right here. So v itself is just this vector here, right? And then I calculated some scalar multiples. So like this bit here is 2 times v, 3 times v goes all the way out here, minus 1 times v is there, minus 2 times v is here. But I want the line generated. Well, the line is simply the extension of this forever, right? This goes on and on forever and ever in both directions. This is the line generated by v. Okay, I should work out the equation of the line because it tells me to calculate the line, not just draw it. Well, I could try and work out the equation of the line in two methods. One method is I'm going to choose 2 points. So I'll choose this point here and this point here, and then I'm going to use the equation for calculating the equation of a line, which we spoke about in a previous video. So this point here is 0, 0, and this point here is 2, 1. Okay, and remember the equation of a line is given by y minus y1 equals m x minus x1. And if I let this be x1, y1, this be x2, y2, then this turns into y minus 0 equals m x minus 0. I just need to work out what m is. And if you recall, m is equal to y2 minus y1 divided by x2 minus x1. So I have that m is equal to 1 minus 0 divided by 2 minus 0, which is just a half. So that means the equation of the line is equal to y equals a half x. And that's the answer. Okay, that's the equation of the line generated by the vector v equals 2, 1. There's a theorem which tells you the equation of the line generated by a vector in general. Okay, so this theorem tells you that the line generated by the vector AB, it depends on what A is. So if A is non-zero, then that line is y equals b over ax. And if A is equal to 0, then the line is just x equals 0. And this is consistent with what we had up here, because if you think about the line generated by v equals 2, 1, then A is 2, b is 1, and the answer I got is y equals b over ax equals 1 over 2x. Okay, so this is a theorem which tells you the equation of the line generated by a vector, so you don't need to do this work here. Not that it's much work, but it just tells you a shortcut to get to the answer. So for example, the line generated by something like 7 minus 5 is y equals, so a is 7 and it's not equal to 0. So that means I'm using this case right here. So that means y equals minus 5 over 7x. And that's the answer. Okay, easy as that. Next up, I want to talk about something which is very similar to the line generated by a vector. This time it's called the ray generated by a vector, v equals ab. And a ray is simply a half line, and a half line is literally half a line. Okay, so the ray generated by a vector is the half line obtained by taking all the positive scalar multiples of the vector. So when we spoke about the line generated by a vector, if you recall in our picture, we took all the positive scalar multiples, which took us up in this direction, and we took negative scalar multiples, so like -1 and -2, which took us in the opposite direction. Well, when it comes to rays, you only take the positive. So let's just quickly look at what this looks like. This is a really simple example. It just says draw the ray generated by V, and I've drawn V on the diagram for you. So all you do is you take all the positive scalar multiples of V, which are just going to stretch this up forever in this direction here, but nothing in this direction. So you don't go backwards. You only go up in one direction. So that there is the ray generated by V. Okay, you should think about the ray generated by V as like, I don't know, like if you have a laser pointer or something at the origin and you point it in the direction of V, it's the line the laser pointer traces out. Whereas, I used the word line, okay, it's the path the laser pointer traces out. Whereas the line generated by V is like a two-way sort of thing. Okay, that's the end of this example, and that's the end of this video.